Core 6, use congruent triangles. Our objective is use congruent triangles to prove corresponding parts are congruent. When we use one of our shortcuts, side, angle, side, 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 angle, side, angle, angle, side, to prove that triangles are congruent, we only have 3 out of 6 parts congruent. That's why they're a shortcut. We don't have to show all 6 are congruent. We just show 3 are congruent. What about the other 3 parts? Once we show the triangles are congruent by the shortcut, then we know that all 6 parts of both triangles are congruent, even though we haven't marked or we're not given that some of them are. We call this, saying the other parts are congruent, we call this CP-CTC. You'll need to memorize those initials because you'll use it a lot in proof. CP-CTC stands for, and you'll also put a star by this because you'll need to define or name this on the test. CP-CTC stands for corresponding parts of congruent triangles are congruent. It makes sense. Those corresponding parts in the congruent triangles are congruent. CP-CTC. Explain how you can use the given information to prove that the hang glider parts are congruent. So we have angle 1 congruent to angle 2. So I think it's talking about these outer angles here. These 2 angles are congruent. RTQ is congruent to RTS. These two angles are congruent. And QT is congruent to ST. First we have to show QRT is congruent to SRT, and then we're going to use the corresponding parts. So, we've got on these outer angles 1 and 2. This smaller angle is supplementary to angle 1, and on the right side, this small angle in the triangle is supplementary to angle 2. We have the theorem that says supplements of congruent angles are congruent, right? So by supplements of congruent angles are congruent, we can say this angle is congruent to that angle. So that was another thing we'd mark in the hang glider. So this angle is congruent to this angle. By supplements of congruent angles are congruent. Now, how are the 2 triangles congruent? Which congruent shortcut? Which shortcut are we using? Looks like angle, side, angle to me. This angle, this side, and this angle is congruent to this angle, this side, and that angle. So they're congruent by angle, side, angle. So because of that, we can show looks like we had to prove that QT is congruent to ST. It doesn't state that clearly, but we have to prove QT is congruent to ST. So let's change this a little bit. I'm going to take those marks out. And what else is congruent in the two triangles now? There's something else. They share a side, right? They share that side. RT is congruent to itself. So we've got RT congruent to itself. So now we've got side, angle, angle. That's how I would say the triangles are congruent. The triangles are congruent by side, angle, angle. And then now I can say QT is congruent to ST. We'll do it in a different color. We can say these two lines are congruent, and that's by your corresponding parts, CP, CTC. We didn't know they're congruent until we showed the triangles were congruent. Then as a result of that, then we can say the sides are those two sides are congruent. So yeah, they used angle, angle, side. And then by CP, CTC, QT is congruent to ST. Any questions? Okay. Here's another proof. We have to prove A is congruent to C. This one's a little bit more straightforward. So let's do this proof. The first thing we have to do is prove the triangle is congruent, then we'll use CP, CTC to show that A is congruent to C. So how would I start this out? How would I start this proof out? Tommy, get your head out of your hands. Tommy. Yes.
AD is congruent to CD.
What's that?
AD is congruent to CD.
Yeah, we'd start with our givens, right? So we've got AD. Let's do it in red. AD is congruent to CD. And that's given. All right, what else can I say? What's my other given, Carly?
That AB and BC are
Right, AB is congruent to BC. That's given. Okay, now we've listed all the givens, but there's something else that we can say is congruent. What else can we say is congruent in those triangles? Yes, Carl, Abby.
BD is congruent to itself.
Which one?
BD.
Yeah, BD is congruent to BD. And that's by reflexive, same segment. All right, very good. Now, what would be my next step in this proof? Evan, what do you think the next thing I would say would be?
Angle B is congruent to, right, ABD is congruent to angle CDB.
Okay, triangle ABD is congruent to triangle CBD. And how is that? Which shortcut is that?
Side, side, side.
Yeah, it's by side, side, side. Okay. And then step 5. Well, we know the last step is what we had to prove, right? So angle A is congruent to angle C. How would I know that? It's an unmarked part. We didn't know it until we proved the triangles are congruent. Which reason is that we can say A is congruent to C? Aaron? Yeah, that's where you use CP, CT, C. CP, CT, C. So, on CP, CT, C, you will never say triangles are congruent by CP, CT, C. It's always parts. And it's always going to come after a congruent shortcut. After you've shown triangles are congruent. The common error is people will say these triangles are congruent by CP, CT, C, and then they'll say the next line is a shortcut. Can't happen. The shortcut is the three-letter congruence reason, side, 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 side angle, side, etc. That will always come before CP, CT, C. Never say triangles are congruent by CP, CT, C. All right? Okay. It's always for parts. Just an angle and an angle, or a side and a side. Surveying. Use the following method to find the distance across the river from point N to point P. Okay, we can measure on the land, we can measure distance, but we can't measure across the river. So we're going to place a stake at K on the near side, so NK is perpendicular to NP. Let's mark that. Well, we'll see what all our givens are first, and then we'll mark it. So NK is perpendicular, and then find M, the midpoint of NK. Locate the point L so that NK is perpendicular to KL, and L, M, and P are collinear. Now we can mark it. That's what, if we marked those given things, this is what our picture would look like. All right? We have to find this distance in P. So how could I find NP? If this is over water and this is over land, what's our plan? What can we do? Well, what we could do is that we can measure this distance LK, right? If we can find LK, then we can, and show that it's the same as NP, then I could know what that distance would be. So we have to show these two triangles are congruent. So what else could we mark congruent in the triangles? Yeah. The vertical angles, right. I could mark these two angles congruent. Right? So then, the triangles, we could say triangle MKL is congruent to triangle MNP by which congruent shortcut are those triangles congruent by? Evan?
Angle, side, angle.
Right. Angle, side, angle. I start at this angle, then I have a side, and then we have an angle. So that'd be angle, side, angle. And then I can say that now how can I show that LK is congruent to NP? What am I going to use there? Logan? I've shown the triangles are congruent. What's our next step? What have we been doing? How do I know the parts are congruent? Kennedy? Right. I can say NP is congruent to LK by CP, CT, C. So assuming we could measure this distance LK, we could figure out the distance across the water using the congruent triangles. Complete the proof. So we're given yx is congruent to wx. Those things are marked congruent. And zx bisects yxw. So first statement. How do I know that yx equals wx? Eric. Number one, first thing. What is usually the first thing? How do we know it? Given. So first thing is given. What about zx bisects yxw? Gage?
It's given.
It's given. Good. Then step 3 says yxz is congruent to wxz How do we know that? Seth, you know? Anybody? Aaron? Right. It's from the step 2. From the previous step. That's definition of bisector. So we've got those things marked congruent. XZ congruent to itself. How do I know that? Seth? Reflexive. Good. So that's reflexive. Tommy? Reflexive. Now it says yxz is congruent to wxz. How do I know the triangles are congruent? As marked, how do I know they're congruent? Jacob?
Side angle side.
Right, it's side angle side. Now, how can we say yz is congruent to wz? Zach? Nope, we've already used it. We've already got the triangles congruent by the shortcut. What naturally follows after that? Now we want to show two parts are congruent. What do we use there? Aaron? Yeah, that's where you use your CP/CTC. A lot of times in these proofs, if you have to show parts are congruent, your final reason is going to be CP/CTC. It comes after the congruent shortcut. So that's going to be CP/CTC. Questions? All right. Next section. There's a thought. Four 7. Use isosceles in equilateral triangles. Our objective is to use theorems about isosceles in equilateral triangles to solve problems. First, let's name an isosceles triangle. The base in an isosceles triangle is the non-congruent side. the third side. These two are congruent. The side that's not congruent to these two, unless it's an equilateral triangle, in that case, any of the sides could be the base. But in this case, this is the base. The base is the third side of the isosceles triangle. Base angles. The two angles adjacent to the base. This angle and that angle. They touch the base. Those are your base angles. The isosceles triangle has exactly two congruent sides. The congruent sides are called the legs. And angle formed by the legs, or the angle formed by the congruent sides, is called the vertex of the isosceles triangle. Vocabulary. Base angles theorem. If two sides of a triangle are congruent to the then the opposites, the angles opposite them are congruent. So that's saying I've got these two sides congruent. The angles opposite them, this angle and this angle, are going to be congruent. Now you can call that the base angles theorem, or you can just say in your proof, if for a reason you say opposite sides, I would write it as opposite sides congruent, comma, opposite angles congruent. That's saying if the opposite sides are congruent, the opposite angles are congruent. You can use that as a reason in your proof. Converse. The converse of that says if the opposite angles are congruent, then the opposite sides are congruent. So you would write that as opposite angles congruent, comma, opposite sides congruent. Converse of the base angles theorem. Any questions? Copy and complete each statement. So if HG is congruent to HK, then which two angles would be congruent? According to the rule we just defined. Gunnar, which two angles would be congruent if HG is congruent to HK?
Angle G, angle K.
Yes, because those are the opposite. We've got the opposite sides, so those are the opposite angles. So angle G would be congruent to angle K. They use 3 letters. We should use 3 letters because angle K has 2 possible angles there. So the correct thing would be to say angle HGK, or you could just call it angle G, but the other one you would have to call angle HKG. All right, so now we've got angle KHJ. This angle is congruent to angle KJH. That angle. Those two angles are congruent. Then, which sides could we say are congruent? Logan Calloway, which two sides can we say are congruent?
HJ and HK.
HK and what?
HG.
Nope. Here's the angle. The side opposite is KJ. The side opposite this angle is HK. So we would say it'd be HK and KJ. HK and KJ are the sides opposite the congruent angles. Do I have it? All right. More theorems here. Corollary to the base angles theorem. If a triangle is equilateral, then it's equiangular. Because in an equilateral triangle, all the opposite sides are congruent, so that means all the angles are going to be, opposite angles are going to be congruent. Corollary to the converse. If the triangle is equiangular, then it is equilateral. Everybody have it? All right. Find the measures of P, Q, and R. What do we know about P, Q, and R? Because this is obviously an equilateral triangle. What do we know about P, Q, and R? It's measured. Yes?
They add together to get 180 degrees.
That's true. They're going to add together to be 180. What's the other thing we know about them? From this corollary we just defined, Logan. Yeah, they're all equal. So P, Q, and R are all the same. So if they're all equal, what do they have to be if they add to 180? Evan?
60.
Right. They're all going to be 60. They're all equal, so you could say 3 times P or 3 times the angle equals 180. So the angle equals 60. Find ST in the triangle at the right. What would ST be? Abby,
5.
how'd you know that?
Because P is 5 and on all the sides are congruent.
Right. This is equiangular. All the angles are the same, so that tells us that all the sides are the same. If all the angles are the same, all the sides are the same. So that means that if one side is 5, the rest of them are 5. So ST would be 5. All right. That's it on the notes.